So welcome back, Colin and Johnny. Small group, but that's cool. What we're going to do today is we're going to go through, I'm going to skip a lot of this. You saw this previously, going to really get into the agenda. So what we're going to be doing today is talking.
Turn this music off.
Yeah, thank you, Scott.
Based on Josh moving around the slides.
Can you guys hear me? Scott, can you hear me? Or okay, so you guys can hear me.
Josh, I don't know if you are talking or not, but I can't hear you.
Hold on, guys.
Is it just me or Josh not talking, or what's going on, folks?
All right, so going to go ahead and continue here, and I'm going to put Scott on mute since he can't hear us. But I'm going to go ahead and continue. So we're going to dive into observability.
Yeah, I got you now.
So, yeah, I know. Thanks, Scott. Cool. All right, so let's go ahead and open up the deck, and let's go ahead and dive in here. My name is not John Meredith. I am Josh Broltheim. I forgot to update this slide, so but all the other content is ready to go. So the objectives for today. This course is more regimented than the other one. So we're going to go through slides. We're going to go through labs similar as we did yesterday or Tuesday. But this one has a little more structure to it. So a little more slide heavy at the beginning, but it's I mean, intentionally so, and for a good reason. But during the session, as it says, we're going to talk about observability solution and the components, specifically the fact that there are going to be 3 pillars of observability, the solution, specifically metrics, tracing, and logs. So we're going to look at all 3 of those separately, together, how Sumo can help you with them, the power of them, and why observability is good. And then we're also going to use, as I said, towards the bottom, our various tools and technologies. So we're going to utilize Root Cause Explorer, which is a pretty neat feature of Sumo Logic. And we're going to show you how it works and get hands-on with it. And then we're going to look at traces as well as a way to troubleshoot the incidences. So that's the plan as far as kind of a schedule. This one, like I said, a little more regimented with timing, but generally doing a welcome, doing an intro, doing a little demo on the tools, that Root Cause Explorer that I mentioned, then doing some labs together, probably take a break around, I don't know, somewhere around there, then do some tracing, demo, and slides, and then a few labs, and then end, and then the exam. So the exam is not on this slide, but it's still going to be part of today. So, all right. It looks like we got a couple other people joining, which is great. Just throughout today, any questions, go ahead and put them in the chat. Scott's helping out with that, and we're just starting here, so you haven't missed much. So good, perfect timing. Today's session is being recorded. Excuse me. So we'll be sending out both recordings from Tuesday and Thursday. Probably, I don't think you got them yet, so probably in an email, probably tomorrow. So you'll get those. All right, so let's get into it here. So what is observability? What are we going to be talking about for the next 3 hours together? So I'm going to skip over this slide. This is our intro, kind of not intro, but a little bit about Sumo. We discussed it yesterday. You already know about Sumo. You kind of bought in for you know, you understand the power, you understand the security behind it. So I don't need to really, I think, remind you of that. I feel like you're committed to us. But I do want to talk about observability because that is well, the topic of today. Now, where is observability going to help us? Observability is the ability to observe and understand the whole state of an application, such as our coffee app. So in this case, we played a little bit, or I described on Tuesday, Sumo Logic Coffee. We're going to get more in detail with Sumo Logic Coffee. So today we're going to act as employees of Sumo Logic Coffee in a little bit, but that's going to be our really focus for our kind of business model for today. So imagine, you know, a company selling cups of coffee out there, and they're good cups of coffee, and now we're expanding to the web and using applications, and you know, in the modern era, and how can computers help us with that? Well, that's how can observability and computers help us with that? Well, with observability, we can observe an app from the outside and understand what's happening in it. Observability helps ensure that the app is running reliably. In other words, the system is up and running, functioning well or as expected, and is secure. Observability makes sure your app's resources are used and accessed as intended under all the circumstances. And so as we're strong here, starting to show what is observability from utilizing an app, being notified something is not quite right, coming to some sort of conclusion, and then taking an action. Very similar to how we looked at the Cloud SIM product in the afternoon on Tuesday. The idea of the system's notifying you, it's using its advanced technology to figure out what to notify you about, and then you make a conclusion based on the puzzle pieces you're presented, and then you take an action, whether it's a direct action, whether it's shipping it over to somebody else to have them look at it, but you do take that action. And then kind of as the chart shows here, and repeat. So doing that a lot, and this is the start of what is observability. Now, there we go. There's 3 pillars of observability, and I mentioned them already, but going to hear them a few times today. Logs, metrics, and traces. And those are going to form the observability solution. They're complementary to each other, and they need to be together in a single platform. And together they can offer more than what a single product can do than in 3 separate products. So together, kind of the whole, the sum of the whole is better than the sum of the parts. I think that's the phrase. But what's the need to have an observability solution? So these are the pieces that make up observability. They need to be in Sumo logic. We're going to look at those pieces both individually and together shortly, certainly together to make up the observability solution. But what is the need to have an observability solution? Now, if you're here, you probably know the need for an observability solution because it's just something that's intriguing to you, if you will. So what I have here is 3 more pillars. We seem to like our pillars, at least the idea of them up on the screen here. And what we have is the 3 of them. So we have the reliability, we have performance, and then we have security. And together those tenets, if you will, form that great customer experience. And that's really the goal, is ultimately to have a good or a great customer experience. And so with the reliability, what we have a couple little stats here that should pop up. There we go. So for example, why is availability important? Well, you need the system to be up and running. And just, a couple numbers, some stats here. It's been proven that 100 microseconds of downtime can reduce e-commerce sales by 1% for a well-known content delivery network service provider. So that little bit of downtime, that 100 microseconds, can result in loss of sales, loss of money, and of course that's not good. Performance, having 0.5 seconds of latency drop traffic for a giant search engine by 20%. Now that's, once again, performance happens, bad reliability, bad customer experience. Maybe that customer now thinks about using a different search engine. And then security, of course, top of mind for everybody. DDoS attacks are anticipated to double by or up to 14.5 million by 2022. And so certainly those attacks that can both tie up resources as well as infiltrate systems can reduce reliability, can harm those systems that customers need to use. Those systems being down or overloaded, certainly a problem, and bad customer experience again. So to ensure reliability, an organization needs to have the unified platform, as well as continuously monitor the app, diagnose the issues, and fix them ASAP. And that's really why there's a need for observability solutions. I put this slide here. I don't know, I thought it was sort of important, but wanted to talk about the difference between monitoring and observability, because they're very similar, but also a little bit different. And so just for a kind of terminology, I thought it was, like I said, I thought it was important. So just to describe or explain the difference. So here we have both definitions. And so a lot of people equate observability to monitoring. But what we find, or what you might find, is when we dig deeper, it's not just seeing about when something goes wrong, but what's causing it, what area it's impacting, and how can we correct it before it impacts more customers or more parts of the application. So how are they different? Monitoring is really about telling you the state of a system by looking at the parts that have been configured to be monitored. If a part of the system isn't monitored or hasn't been configured to be monitored, then we have no idea what's really happening there, and knowing something is wrong is quite important. But with monitoring, you know about the functioning of your apps, its growth, its utilization. And so observability goes beyond monitoring by bringing together those three tenets, those log metrics and traces, to give us a broader view and a deeper context. It's knowing something is wrong, but then also being able to find out why. And so it's just digging deeper. Continuing with the analogy of deeper, we have our iceberg slide. And so what we're trying to show here, or not trying, I think we show sort of successfully, is why Sumo Logic's observability solution. So observability is important. Hopefully you bought into that idea, but it's not unique to Sumo, but we do have a solution that is unique and is the best one out there. So what makes it good? So there's two requirements for an observability solution. Firstly, any observability solution needs to be able to handle large scale data sets. So monitoring and diagnosing requires working with some amount of data. It's that troubleshooting phase where observability systems should be able to handle unlimited amounts of data. And this is a challenge for many observability solutions that don't have a high-end and highly scalable solution. Well, fortunately for you and us, built on a cloud-native architecture, Sumo Logic enables the ingestion and storage of any amount of data in a highly elastic and flexible way. Now, secondly, the observability solution also needs to have a very scalable analytics engine. Observability requires you to analyze lots of data to machine learning and other initiative search-driven analytics capabilities. Once again, fortunately for you, as a large-scale machine data analytics platform, Sumo Logic provides out-of-the-box capabilities to support the ingestion and analytics for almost any amount of data. The observability solution is going to provide tools that work together to ensure all the troubleshooting, monitoring, and diagnosing across our various environments. And what we're showing with this iceberg slide is the idea of, at the top of it, you can monitor your stuff. And as described, monitoring is important, but it's not the full story. And so if you want to monitor, if you want to just get that what is wrong, you need about 20% of data to do that. Now, as we go deeper below the iceberg and more iceberg appears, we're going to need more data. And so this is where, as you want to diagnose, as you want to troubleshoot, as you want to complete that observability solution, the three tenets, you need more data. Getting more data or utilizing more data provides you the benefit of figuring out not just what, but where, and then even why and how. And that's going to just help you troubleshoot, help you do all three steps and figure out what's wrong and how to fix it in a timely manner. All right. Few more slides. A couple more slides here, not too many more. My mouse gets so jumpy for some of these. So similar is what we've started to talk about, but just to continue with the thread. So with understanding the differences between the monitoring and observability, I want to talk about some of the features of the observability solution. Let's see. So once again, just the monitoring that tells you when something is wrong, understanding why. So I think we understand the importance of that. And the solution includes rich pre-built content that you can leverage to quickly start monitoring specific services. So very easy to get out of the box monitoring set up. Now, with traditional monitoring, diagnosing issues would be time consuming and unassured. With the observability solution, you can now diagnose those issues quickly, leveraging capabilities of alerts, out of the box dashboards, multi-dimensional analysis, and as we're going to talk about shortly, the automatic root cause detection and benchmarks. So these are going to be some tools and features that are going to really help with that troubleshoot to complete that. Once again, those three tenets of, these are not the pillars, but these are the three portions that make up the observability solutions. Let's see. The Sumo Logic differentiators. So just, as I kind of talked about, this sums up the past couple of slides. As you want to go deeper, more data is required. As you want to go deeper into your workflow, into really figuring out what's going wrong, you need to get more data. So at the surface level, when you have your monitor, it's very easy for us or you to create a monitor of good, bad, red, green, high, low, and see what's going on, or starting to get an indication of what's going on. But if it's red and it's bad, just seeing that it's bad is helpful, but the goal is probably going to be to fix it. And so that's where you want to get into the where and the why and the how. But what we're trying to show with the workflow is then you start to need to get deeper into your environment. So no longer just looking at your charts, starting to look at the deployment, getting deeper into the cluster, going down to the pod level, even the component level. And then, as we'll utilize today, actually using root cause analysis to figure out why and how. One last slide for this section here is the observability value. So we've talked about, the portions of observability, those, once again, monitoring, diagnosing, troubleshooting, that are continuing to become repetitive. But who can benefit from observability? Well, the SRE and DevOps team, which you probably are parts of just based on those that are attending today. Those are going to be responsible for monitoring the health of applications. You guys need observability so you can quickly monitor, diagnose, and troubleshoot application health issues. But who else can benefit from it? The software engineer on the team, by providing visibility into that software pipeline. By collecting information about that pipeline and identifying the issues with the software delivery process, teams can improve the quality as well as the delivery of their application. And then DevSecOps, those security-minded folks, certainly observability will help them ensure the security posture of their applications. And what's unique about the Sumo Logic observability solution is it addresses the needs of all of these teams and personas in one integrated platform. So yay us. All right, let's see. That's going to be it for a couple slides here. Let me go ahead and skip forward. Let's just jump into here. And certainly any questions, of course, please ask. So just to go ahead and ask in the chat. All right, so let's keep going here. So let's get into Root Cause Explorer. I'm just saying if I should show it through the interface. Let me do my thing here. All right, so here we're going to go. So going to talk about Root Cause Explorer, and this is what it looks like. And actually, let me go ahead and just log into it. I think it will be a little more relevant, and you will be logging in a few moments to play with it yourselves. If you want to log in with me, you can. I'm going to kind of hide the credentials unless you remembered them from last week until I just do a little portion of the demo, but we'll get you logged in together. But like I said, if you remember your credentials, you can play with me. So I've logged into Sumo. We know Sumo. We've gone through Sumo a little bit. You've done it on your own time. What we're going to be using today, or at least for right now, is Root Cause Explorer. So when we log in, or when I log in rather, I'm going to go to Root Cause Explorer. And like I said, you'll be going through these steps in just a few moments. Now, what is Root Cause Explorer? I haven't really adequately described it or anything. What Root Cause Explorer is, and here's a pretty good explanation of it, is it's going to help anyone accelerate troubleshooting and root cause isolation. And actually, let's go ahead and use the little tour here. Why not? I must have moused out of it. So what do we see here? Because this is a wild screen with lots of stuff going on, and let me explain what's going on here. What's occurring is the system is looking at or observing, hence observability, our environment. And what it's starting to do is look for things that it calls events of interest, things that are interesting. And we start to see some of those events of interest on the top kind of legend up here. These events of interest are based off of what are called golden signals, which were created by Google DevOps about 5-10 years ago. And what they are just ways to recognize the stability or the health of a system. Is it having throughput issues? Is it having bottleneck issues, and so on and so forth? Now, what we're seeing here in the bottom, or this middle portion rather here of the graph, and this is the significant portion, are these events of interest. So what the system is telling us just by looking at these color schemes, and we're going to look at these more specifically, but we have some errors going on. We have this purple color, we have some latency going on. We have some load issues occurring. And this is all good, well, good to see, not necessarily good to occur, but this is helpful information. Because right at this view, you saw I didn't really do anything to get into the system besides logging in. I am now being told, or the system is telling me, these things are kind of weird or anomalies. Now, the system is using, or they're displaying it in a graph here. And so what we have on the x-axis is our time component. By default, it's going to be set to 3 hours, but we can modify that and we will play with that a little bit later. But what we see is the x-axis of time. So I see this thing happened, 3 hours ago or 2.5 hours ago, and this thing happened 10 minutes ago. So we're getting that scale of time. The y-axis is indicating drift. What drift is deviation from the norm. So what we're seeing as it gets higher is more abnormality. Yeah, I think that's a good, appropriate kind of word for it. And so that's what is being presented to us. Now we have the ability to filter this information, because right now this is taking all of our Sumo Logic lab data or training data and presenting it, but we can filter that. So we have the ability to use filters. So we can start to filter on just AWS data, just Kubernetes data, application service data. In this case, like I mentioned, we're bringing in just lots of different data, so that's why this is a little more busy. But I could say, just show me Kubernetes data. Now, we're not going to really be using Kubernetes today because that's a different class, but I don't want to show the AWS data. I want to do us to do with that in the lab. So we're seeing these data points. When I go ahead and mouse on any of these data points, I get information about it. So it's telling me the time, the drift, or that abnormality. The more importantly, or equally important, the metric. It's showing me specifically that there's an issue on my deployment, specifically the entity of my SE demo environment with the deployment CPU usage. That CPU is higher than it should be, or higher than normal. Now that's good to know. I probably want to do something about that. Now I'm not for this class, but we certainly could. If I go ahead and click on the circle, on the right-hand side of the screen, I get just more information about this thing. So remember, this is some sort of CPU usage issue. What the system is showing me is some metrics here. It's showing me metrics that it thinks I will find helpful, and I do. Because the metric it's showing me is the metric for CPU usage right now, or 5-10 minutes ago, the CPU usage 1 day ago, and then 7 days ago. And what I'm kind of led to believe here, if you will, is I see the green representing yesterday. And so what I'm seeing is no CPU usage, or minimal CPU usage, no spikes at least. All is good, all is good, all is good, all is good yesterday. If I want to look specifically, we might not even have 7-day data in there. But I do notice the difference of today. It peaked a few minutes ago. And so I'm getting more not visual confirmation, more data and analytic confirmation that this is abnormal. Yesterday it was normal, today it peaked. Why is it peaking today? Well, let's go ahead and find out and fix it, or add more resources, or do whatever we do to it. We also have the idea of entities, which is going to show us more data about our stuff. I'm kind of using the vague technical term of stuff, but it allows us to dig deeper into our stuff. So at this level, and this is Kubernetes data, we're looking at the container level. Well, we can go down to the pod level, the cluster level, the namespace level. We can start to dig deeper or higher up to see what's being impacted here. So here we're seeing the demo sales engineering. We're starting to see CPU usage. We're starting to see pods running. Maybe this explains it. A bunch of pods started, and that explains why we're having that CPU spike. Now, when we do our lab, we'll actually go through a full narrative in this. I'm just kind of guessing. Not guessing, just playing. And let me show one other example. Actually, let me see. I just want to see if this example pops up. If not, we'll just get into the lab and do the example together. Yeah, all right, this one's not that great. So what I want to do is I want to have us go ahead and log in together and start to mess around here. So let me go ahead and put up those credentials. The same credentials you used on Tuesday. If you don't remember them, you can certainly use new ones. It's not that important to stick to the same ones. Actually, it doesn't matter at all. Once you get logged in, let me know. So website, service.sumologic.com, training plus analyst, number, pick a 3-digit number, and then at sumologic.com. And then the password is, once again, security with a capital S, ECURITY, 21 exclamation point. The other thing I'm going to do here, let me see, is I'm going to share the lab guide at this point. Let me. All right, I'm uploading well, it's a big file, a lab guide to the chat. So it'll take a moment or two to get there. So once you get logged in, also download that lab guide, or vice versa, whichever. And then, yeah, we'll just go ahead and wait for a few more. So once you get logged in and get ready, if you can go ahead and either say ready or just put your number in if you haven't already. We'll give you a few moments. If you don't want to participate in the labs, which is perfectly fine, feel free to just kind of sit back and watch, and going to do them together. So you'll get a kind of a good view of them. All right, so just gonna wait a few more moments, and time-wise, we're good. So. While you guys are logging in, let me see. Let me just show my slides, see if there was anything I really missed in here of so we showed that. Hopefully you know or understand that I can help accelerate troubleshooting, as I've been preaching. Going to help in correlation. Here's that not messy view. It's actually a helpful view, just a lot going on. Showed you the filters, showed you the golden signals, and we'll start to use, we'll use them for display. We can use them for filtering. I don't think we do in the lab. The events by time, so that X and Y axis. I didn't show the count by time, but here it is. It's a newer feature, actually. And so what it shows is, I mean, pretty clearly as described, just giving a, instead of a top down, a side view, I guess it would be, of the data. And then on that right side, just the more information. All right, good. Heidi's in as well. Started to show you how to play with those filters, and we'll do this in the lab. So I'll wait just until a couple more are in. Just more filtering. I'll talk about the advanced. I didn't yet. I should. Different views. So we'll poke around with that. This is the whole point of the lab. So I'll show this red box of the, and what we're showing here in this red box is the idea of the correlation of time of in this hour window or so, hour and a half window of the red box, there was an error, there was a bottleneck, all possibly related. And that's what we're going to kind of play with in the lab is, are they related and what's causing them and why, and all those type of things. All right. A little magnifying glass. And then we'll play with the searching in a moment. I didn't really show it, or I kind of quickly did, but we'll do that in the lab. All right, I think I hit all the highlights. So if anybody else needs a moment or two to log in, go ahead and let us know, or of course take your time, but I'm thinking I'll start. I think we're pretty close to good. So yeah. And Scott's here if you need help. So, so you have our lab guide. The slides, these first couple slides will kind of mirror the lab guide for lab 1. So for lab 0, make sure you're logged in. In lab 1, what we want to do is, before we start to do it, although you're welcome to just dive in, just want to give a little narrative, a little story of what we're doing here. Now, I did mention that we were going to use Sumo Logic Coffee, and I didn't lie, but we're going to use that a little bit later. We are going to use Travelogic for this exercise. Now, Travelogic is our other sister company. Travelogic helps people get flights, hotels, airfare, car rentals, and checks rates, and very similar to other popular travel websites out there. And so for today, you've been hired as a member of Travelogic, and so we're going to put you right to work, because busy time of the year for us. I don't know. So what are you doing at Sumo Travelogic? Why did we hire you? Well, we hired you as a DevOps specialist because we want you to support the Travelogic application on AWS. Specifically, we want you to focus, or the application focuses on 3 AWS services: ELB, which is the application load balancer, Host EC2, and DynamoDB. So those are your areas of focus, expertise. Certainly going to be kind of wanting to look at that information today. So that's where the lab will drive us to. And so first day, well, guess what? End users are experiencing an outage in the application. They're getting 500 errors, specifically in the US East 1 area over the last 24 hours. So being a DevOps specialist, your challenge is troubleshoot and figure out what's going on. So first day, your manager or the system lets you know, 500 errors, US East 1, last 24 hours. Manager says, go fix it. Good luck. So let's go, let's fix this. Let's see what's gone wrong or how to resolve it. And so to help us on our first day of work, we have a lab guide. So, which is realistic. You often do get kind of playbooks like this. So this is not that abnormal. So I'm going to go ahead and jump into Sumo Logic if I'm not already in there. When I first logged in, brought to the home screen, there may be tabs open already. Feel free to close them. But what we want to do is we want to go specifically into, actually not Root Cause Explorer first. We want to go into the Explore tab. Now, I haven't shown the Explore tab yet. This is kind of new. I guess I should have at least mentioned it, but I want to show you what's in there because it's going to be quite helpful, especially with the observability solution. And like it says, you can go directly to root cause, but I want to show Explore in just that view. So I'm going to go up to New and Explore, or I can go to Explore, the green button, either way. And what I'm presented with is what we call our Explore tab. Now, by default, there's probably nothing in here, and that's just because this coffee bar training app is loading up automatically. What I want to do, though, is I want to modify my Explore by. I don't care about Kubernetes data because this is not a Kubernetes class. If it was, I'd be more concerned about why these are empty. What I want to do is I want to go to Explore by, and I want to choose AWS Observability because that's what we're talking about today. When I select AWS Observability, what I should be provided with is graphical information. I specifically want to go to prod. This is showing me my different accounts or different environments. And we have some different ones set up just because it's a training environment. So I don't want you to use the 821 or the mobile banking. That's just different stuff. But what I do want to do is go to prod and US East 1, because remember, we're in charge of or we're at least being told to look at the US East 1 region, and this is production data, so we want to go to prod and US East 1. From this Explorer view, though, we could have gone to US East 2. If US East 2 is our focus, I'm now looking at US East 2 data, and I'm looking at all these pre-built or pre-canned, pre-built, pre-canned, same difference, dashboards that allow me to get information about my AWS environment. So this is live, essentially. This is my AWS environment. This is showing me where people are logging in from. As we discussed yesterday or Tuesday, from a security standpoint, if you see somebody coming in from China, that might be a problem, but that's not the focus today of security. But resource management or part of it. And so what we're starting to see here is exactly that. Resources being utilized or overutilized. Now we're going to go to prod US East 1. And what we're going to see here is, like I was alluding to, just a lot of different data, ALB data, and we're going to use some of these shortly to investigate what's going on, Lambda, just all different aspects of AWS environments. Now, in the right pane, what we want to do here is we want to go up to dashboards. And we should, there it is, have a AWS region events of interest. So what I'm doing here is I'm going to my US East 1, my area of focus, and I'm going to look at events of interest instead of the overview. There's other ones, we just don't use these for this class, but there's other dashboards that can be preloaded or, preloaded. But I want to look at events of interest because I want to look at events of interest. I want to see what the system is finding interesting. And that's really what's being shown here. Now, what I'm looking at here is kind of call it like Root Cause Explorer Junior. It's not as robust as that interface I showed earlier, but it shows significant things in that it shows our x-axis of time, our y-axis of drift. It shows latency. So I'm seeing some latency here. More importantly, I'm seeing some errors here, which is probably going to be relevant to our lab of errors. Remember, I'm trying to figure out what is causing 500 errors. I'm now starting to see these errors. Specifically, if I see this metric, I see an ELB 500 error count. And we'll go into this a little bit closer in the next portion of the lab. Right now we're looking at this panel. We'll dive into the full Root Cause Explorer in just a second, but wanted to just show this as another way to see what's occurring in the system. Now, to get back into Root Cause Explorer, what I want to do is I either want to go to New and Root Cause, or from this panel, I can click on the three dots and go to Open in Root Cause Explorer. I'm going to go ahead and do just a new Root Cause Explorer because this is going to filter everything for me, which is great. This brings me to specifically what I need, but I want to show the broader filtering through the Root Cause Explorer. So I'm going to go to New and Root Cause. Oh, I can't do two of them. That's right. New and Root Cause. Come on. Let me see. There we go. It's loading. Yeah, there we go. That was weird. So I want to go into Root Cause Explorer. And then what I'm going to do is I'm going to use the filters. So at the top, I'm going to go to my filtering. And I'm going to go ahead and turn off the Kubernetes, turn off the application services. Because for today, that's not what I'm interested in. I'm interested in AWS data. In this case, this is an AWS kind of example. And so that's all I care about. Now, specifically with my AWS stuff, when I go to account, the other thing I need to do here, I'm sorry, is extend the time. Probably going to last 24 hours is going to be the best. And in hindsight, doing this through the steps through the lab is probably more efficient, but I think it's worth just showing these couple of items in here. So we're going to do last 24 hours. And then what we're going to do is we're going to start to filter. Why is it not in here? What I'm looking for is should have a prod. And it doesn't. That's weird. Let's just do US East 1. Let's see if this works. Okay, so we're going to make sure that for the region we choose US East 1, and everything else we can actually leave as is. Yeah, we can just leave as is. So what we want to find, or hopefully you're seeing, is a large cluster that looks very similar to this. And if you did the last 24 hours or any extended time period, you might notice it repeats. So what we're looking for is really, kind of like what this looks like: a bunch of oranges and a red. And what I can do here is I can go ahead and zoom in on them by clicking on left of the EOI graph and click and hold down and drag to the right. And so what that is just zooms in for me, which should be helpful. Now, what are we starting to see in here? Let's start to actually click on some of this stuff and try and figure out what's going on. So what I'm going to do is I'm going to first click on the error, because this is directly related to what's relevant to me. This is a spike in 500 count errors. And that's exactly what I'm being told is a problem, or is what's being reported as a problem. Now, it's great that I see confirmation of these errors. And if I look at my graph, I start to see that they deviate from the norm, in that yesterday during this time, there were not a spike of 500 errors. There were some errors, but minimal. But today there was a spike. And last week, same thing. At this time, there was not a spike, but today there was. So this is letting me know this spike is kind of weird. So once again, good to know that these 500 errors are occurring, but now I need to go back in time or get a better picture of the story and figure out what's causing those. Those errors just didn't magically happen. Something happened or didn't happen that caused them. And that's what I'm trying to find here. So what I want to do here is and if we're using the lab, we're on about step 7. I guess about step 7 or so. And what we can do is we can go ahead and let me filter this by account. Let's see, Yeah, this helps better. Okay, so what I want, I'm filtering by account and I'm filtering by region of US East 1. And the reason I'm doing that is so that I only get 2 points in here, which is really what I want. It just cleans up the screen a little bit more. So what I now see is, and if you need help getting to that, let me know. I apologize for a little kind of run around with that there. But so what we see is we see our 500 error is bad. And what we see is preceding it, something happened. A CPU load average, a CPU spike related to US East 1 and our environment, specifically a bottleneck. So same idea, something happened or didn't happen. And as a result, the CPU spiked and then 500 errors occurred. So what caused the CPU spike? Well, let's go a little bit further back in time, if you will. And what we see here is a very good indication of what occurred. What we see here is the fact that a DynamoDB bottleneck related to right throttle events. And similar as we've seen or described, we see that spike that didn't happen yesterday, didn't happen a week ago, but did happen today. So now we're starting to get some more information of what might have occurred. We're still not there yet, but we're starting to see, well, probably something with DynamoDB happened related to those spikes. So what we're going to do now is we're going to go ahead and click on that DynamoDB if we haven't already. And on the right-hand side of the screen, we're going to select, we tell you to select infrastructure. It's been changed now to entities. Same difference, just name has changed. So I apologize, that's not updated. I thought I did update it, but we're going to select entities. And what we're seeing here are these relevant entities and as it says, environment parameters. So we're starting to see more information about what was going on at this time. What we can do is we can go ahead and open this entity. So this is the DynamoDB. This is the thing that is causing latency or has increased latency. And we can choose to open it in the entity dashboard. So we're going to go ahead and click on open in. We're going to click entity dashboard. And what we should get, fingers crossed, is our capacity planning DynamoDB. So what has happened is, or what's happened is the system you have asked the system to bring you to an entity dashboard that has graphs and charts related to DynamoDB. So essentially you utilize the AWS observability window that we showed earlier and filtered down to exactly where you wanted to. You could have physically clicked on stage, clicked on US East 1, so on and so forth, but you wouldn't have really known that there was a problem there. This is us using Root Cause Explorer, and now we're getting to where the problem is. Now, we don't know what the problem is yet. We don't necessarily know why DynamoDB is spiking or higher than normal, but we know it is, and the system's telling us, hey, check this out. This might be relevant. What we're going to do here is we're going to go ahead and utilize one of the dashboards. So by default, it brings us to dashboard 1. I guess that makes sense. We want to use dashboard 3, the events one. Because with the events dashboard, we want to see the events that have occurred. What has happened in the DynamoDB realm? Well, something has probably happened that's caused a spike, that caused a bottleneck, and then caused caused the 500 errors. And so let's see if we can find that thing. So we're going to select events. And we should see a couple events. And we do. And what we want to do here, and I get nervous because sometimes the lab goes a little wacky here, but let's give it a try, is we should be able to go to top errors. We should be able to click on the 3 dots next to the far right of the top errors panel and go to open and search. It's going to show us about the new search page, which is great. Now what we're doing here is we're starting to look at the log messages to see what has occurred, because what we want to figure out is what has occurred. Why did that spike? What event happened or didn't happen that kicked off all this chaos, if you will? So now we're looking at our log environment. What we want to try and do here is, let's see, I hope this works. We want to go ahead and deselect the attribute definition fields. Let's see if we can find that. And I think this got changed recently. What I'm looking for though, let me see if I can find it. Let's see, I don't, so let me see if we can just find that last piece. What we're trying to find is what happened to cause the issue. And what I'm looking for is I should have a log message that shows that somebody has changed a parameter. So that's what I'm looking for in here. It should be in there. It's an update table. I don't want to take too much time just looking for this because it's not that exciting. All right, well, we can use this. We can use this message, I guess, as our big reveal. What we're seeing essentially is there was a validation error. The provision throughput write capacity units failed. What I was hoping to show you was a log message that showed that Mike or a user actually made that change. And so the idea would be that that individual made that change incorrectly, just made a mistake, and that kind of resulted in everything breaking. And so the idea is, if we go back to our root cause explorer, the idea is that right about here, Mike made a change to the system. The change was a bad change and resulted in the right throttle events of the DynamoDB bottlenecking and just getting higher than normal, a lot higher. That giant spike resulted in a CPU load average, meaning more resources were needed, and those resources might not have been available. And so 500 errors are starting to occur. And so, like I said, that was the goal of that lab. I apologize, it got a little bumpy towards the end, but that's what happens when you do a live demo. So, but hopefully, as a, for the root cause explorer, the idea behind it was understood. So let's go back to some slides here, just to make sure I kind of told an okay story with it. So let me just get back to my slides. And specifically this one. And this is a slide. I don't know if I should have shown this before or after, but what this is revolving around is just some of the troubleshooting concepts that are involved in the root cause explorer. So to sort of review some of these, I sort of discussed them through the presentation, but not all in one. So first one is abnormal spikes. So what are the concepts that really accelerate troubleshooting in root cause explorer? So what concepts are important? Well, abnormal spikes are important. An abnormal spike is a statistical anomaly, and those are going to typically indicate an underlying issue. Longer spikes compared to the expected baseline and longer lasting spikes require closer attention than other spikes. So that's one thing that's really important in root cause explorer or troubleshooting, is seeing or noticing those abnormal spikes. Another one is context and correlation. So analyzing those spikes with context and correlating them with the events of interest are essential strategies for root cause exploration. In large deployments, thousands of AWS CloudWatch, tracing, or Kubernetes metrics may be anomalous over the course of an outage or incident. So it can become impossible for an on-call user to deduce which resources may be related to the root cause. With the ability to correlate with the events of interest based on context, Root Cause Explorer can significantly accelerate those incident triage and root cause isolations. And so, for example, in our lab activity, the application experienced throttling at the DynamoDB level, also exhibited symptoms at the EC2, the ELB target group, the ELB levels. We didn't look at those too closely, but there was certainly, we see some of those. And so Root Cause Explorer leveraged the insights to correlate those events of interest based on other dimensions, including time range, AWS region, AWS namespace, and using some of those filters, we could have delved into those as well. Connections. So connections between resources and services help us understand the topology in those related events of interest and can help gauge the root cause in a complex system. Knowing the connections between the resources and the services they serve can help a user trace problems from top-level symptoms to upstream root causes. RCE uses connectivity data from Sumo Logic Tracing, service maps, AWS X-Ray, Kubernetes, all these other environments to group and to form those events of interest. Earlier spikes, this is probably more obvious, but earlier spikes are closer to root cause. In a complex system, resources or services that break at the earlier stages of an incident are closer to the probable cause than resources that experience spikes later. Root Cause Explorer exploits this insight to display those spikes on a timeline, so giving you the benefit of seeing what is early versus late or more recent. A few more concepts here. Two more. The fifth one is around the exploration of log and trace data. So identifying actual root cause requires exactly that, exploration of log and trace data. You need to drill down to the event logs and trace the actual root cause based on the previous analysis to pinpoint the actual root cause. Root Cause Explorer helps triage the first level of root cause, which can then drive quick recovery. However, it's also important to understand what caused the system to get into that state that caused an incident. This can require exploring logs associated with the application of microservices. And then finally is the sixth concept, these golden signals. And site reliability engineers are typically familiar with these golden signals of load, latency, bottlenecks, and errors. In a nutshell, those errors and latencies are signals that most affect users because your service is going to be either inaccessible or slow. Root Cause Explorer classifies each AWS CloudWatch and Kubernetes metric into one of those golden signals to help users navigate spikes using golden signals and arrive at the root cause. All right, so that concludes the portion on Root Cause Explorer. Going to go ahead and check for any questions.
We're good.
Cool. Let's keep going. So tracing is going to be the next portion. Now, traces are going to be an essential pillar of observability because they're going to provide context for the other components of observability. For instance, you can analyze a trace to identify the most valuable metrics based on what you're trying to accomplish, or the logs relevant to the issue you're trying to troubleshoot. So when we're talking about this tenant, three tenants of three pillars of observability, started to talk about logs, a little bit about metrics, and now we're going to start to dig into tracing. So traditionally, metrics have been used to provide classic monitoring, but it only looks for the known failure conditions of the application. Observability, on the other hand, requires you to completely understand the application so that you can identify, troubleshoot, and fix any conditions, known or unknown, about the application and its health. To gain insights from the collected data, just collecting and analyzing metrics is not enough. It requires more than that. When used optimally, logs and metrics might be sufficient for understanding the performance and behavior of individual systems. However, they're not sufficient to understand the lifetime of a request that traverses multiple systems. Distributed tracing, also known as tracing, is a technique that addresses the problem of bringing visibility into the lifetime of a request across several systems. Troubleshooting problems real time in distributed, dynamic cloud and microservice environments is very difficult. Transaction traces makes this a lot easier by letting you see details about what exactly is happening and how it affects your users. So what's tracing? Tracing is a significant technique used to used in monitoring modern apps that use distributed microservices architecture. A transaction trace gives a detailed snapshot of a single transaction lifespan across your application environment. A trace follows the course of a user's request or system call from its source to its ultimate destination. You can use transaction tracing to profile and monitor microservices-based app architectures, locate failures, and improve performance. In fact, logs, metrics, and traces serve their own unique purpose and are complementary. In unison, they provide maximum visibility into the behavior of the distributed system. Hence, they're the three pillars of the observability system. In a microservices environment, when customers facing issues occur, it can be difficult to track down what service is the culprit root cause of the issue. One transaction or call from the customer could potentially interact with dozens of services. Transaction tracing provides engineers, SERs, developers the observability needed to quickly identify the problem services with transactions. This speeds up the mean time to identify issues. So what is tracing? More simplified version of it. Think of it, like you get a package. You get something shipped to you and you're able to follow along where it originated from, where it's destined to, which is probably your location, and all those stops along the way. And you can see that it got hung up in the middle of nowhere and got incorrectly diverted to a city that you've never been to. And ultimately it should arrive to your destination. And if it doesn't, using that tracing can help locate where it is if it didn't get to you. So if it didn't get to you, you can see it's, God knows where. So that's just a kind of a real world example of how tracing can be helpful. All right, a couple more slides here, and then we'll get into our lab again. So observability at a glance. Tracing plays a crucial role in tracking let me take that again. Tracing plays a crucial role in tracking transactions of an app on a microservices-based architecture. So even a simple 3-tier application like Sumo Logic Coffee, which we're going to use that example shortly, requires going through a load balancer, a few servers, a database. Observability means being able to ask any question you need about your application and how customers are interacting with it. With Sumo's query language, you can do this with logs and traces. And this is a really large differentiator. No other tool provides the ability to slice and dice your span data using a powerful query language like Sumo's does. And what we need is a view into the app's environment. And so we're going to talk about some of those views now. And so let's go ahead and do so and start to utilize our Sumo Logic Coffee example. Now, this is really kind of a rehash of a little example of tracing, giving that example of that package. And kind of the same idea with tracing of showing here the different steps that occur. So as we start to migrate to our Sumo Logic Coffee example, you're going to log in and you're going to go through a certain path. You're going to place your order, you're going to pay, you're going to log out. And all these are various steps along the journey. And hopefully that journey is successful and timely. And if not, we want to figure out why and not have a user tell us the journey was bad, but we want the system to start to indicate to us this was not a good journey for an individual and figure out why. And that's kind of the story here. So let's go ahead and jump in here. Of course, any questions, please ask, but I think we're good. We'll take a break here. Let's see, when are we going to take a break? We'll take a break after this portion. So yeah, another probably 10 minutes or so. All right, so let's go in. And hopefully you're still logged in. If you're not, that's okay. Actually, the way I'm going to do this portion is I'm going to navigate, kind of walk through, and feel free to walk through with me. So some of these components don't necessarily have full labs with them, but we might do kind of a guided tour thing. So let me start with the guided tour, at least the first couple of slides to set the stage here and introduce you to the Coffee app. So alluded to it a few times today, Sumo Logic Coffee. We have thousands of locations around the world. We sell a hot cup of coffee. You may know a similar company that has a green logo, same idea, just for copyright reasons, we can't use them. So that's our business for today. Now, what is a successful order at Sumo Logic Coffee? Well, it's kind of simple. You come in, you place a coffee order, and you leave, but there's more to it. And the app is going to help here because our app is going to provide services in various locations globally. And we're going to use microservices like user login, order registration, water services, payment services. Each step is going to be a microservice. And each step, when you place an order for a cup of coffee, is really a microservice. So from a technical standpoint, it's using those microservices, but it's steps. You go to place your cup of coffee order. Now, in this case, we're going to use an app, but the order is going to post to our barista. Our barista here is going to start the coffee machine. Coffee machine is going to do most of the heavy work in that it's going to make sure it has proper ingredients. It's going to check that it has the right number of beans or the right amount of beans. If it does, it's going to grind those beans and start to get that cup of coffee. Coffee needs water. The machine needs to make sure it has the right amount of water. If it does, it will dispense that water. the magic of coffee is created and the coffee is ready for a customer. Now, unfortunately, at Sumo Logic, Sumo Logic Coffee, we are a for-profit organization. We're not doing donations, so you do have to pay for your order. Using credit card, let's say we don't take cash anymore, the credit card needs to be approved. You can't just swipe your credit card, it has to get validated. Once that's done, then the customer can pick up their order and leave with a cup of coffee. So in that regard, each step is like a microservice. Now let's bring this back to tracing, which kind of the story here. How does this relate? So here we have an example of a user. So how can we trace a transaction horizontally across the services in the coffee app? So here on the left-hand side of the screen, we have Abel. He's our coffee lover, big fan of Sumo Logic Coffee, and he places his order for a cup of coffee using our cool app. The app does what it does. The order gets to the barista, prints out, and the barista now starts the machine service. So as described, the barista initiates or interacts with that machine, make sure it has the appropriate levels and services and water that it needs, and then it will start to do its thing. Now, at the same time, the payment portion is going to be executed. So the system is going to execute SQL commands and look at the pricing of a cup of coffee and taxes and other fees or what might need to be added. And we start to see our duration. So that's what we're trying to show here is it might take 9 milliseconds for the machine service to start interaction, 5 milliseconds for the payment service. Certainly lower is better. We want to get a fast cup of coffee. As we might see, what if it takes 10 seconds to interact with the machine service versus 9 milliseconds? Well, that might be a problem. It might delay that cup of coffee and then bad customer service experience. So we can start to see what's going on here. There we go. Actually, no whoop, because we can go to the next slide here. So how does tracing work? So as described, client, in this case, Abel, is going to order the cup of coffee. The barista is going to get that order and prepare it and then deliver it, along with the other things of payment and all that. When Abel, the client, orders the coffee and waits some time for the barista to prepare that cup of coffee, we can visualize this entire transaction in a span, and that's what we're starting to see here. The span has a beginning and an ending time, as well as some detail or tag about the type of operation being performed. Well, the client knows about the request and the response, including what he ordered, when it was ordered, what he received, and what he received back, and when he received it. The barista also knows something similar, but from his or her own perspective of when the request was received and responded to. So the client knows when they placed the order. The barista knows when they received the order. Theoretically, those should be similar times, but they might not be, and this is where tracing can help. And so even though the ordering and receiving coffee is a single transaction, it goes through those number of steps. And as mentioned, those steps are essentially small spans with beginning and ending times and being tracked closely. So a transaction will actually consist of several spans. What's missing here in this picture is a third entity that can link the client and the barista to track the transaction span by span. So that's what's missing. We have he said, but we need kind of a source of truth almost, if you will. We need what we call an observer. So in order to start creating a complete picture of the interaction, we need that outside observer to gather information about the interactions between the client and the barista. And with the help of the observer, you can actually look at the interactions holistically and gain better insights. So here, along with the Sumo tracing, we see our observer, and now we're starting to see different periods or things that have happened. So the interaction might happen like this. The client sends the order to the barista at time 0. The barista then receives the order or the coffee request from the client at time 1. The barista might process the request at time 1A or time 2. The coffee is then received by the client at time 3. And so in those respects, they all are observed by the observer. And then what we start to see here is, or are those spans and traces, the spans being each kind of component with that beginning and end time, and we start to see what happened. And as we see, a successful order got delivered. Client ordered, barista received it, barista processed, barista got the machine going, machine spit out what it need, barista responds to the client with coffee delivery time, and then the client receives at time 3. All right. So that's traces. We're going to, let's see, when should we do the lab? We'll do the hands-on exercise at the end. Let's do a few more slides here. And let's see. So next is service maps. Let's do service maps. Let's get through these. These are pretty quick too. I have slides, but I'll use the slides for now, then I'll show it later. Service maps, pretty easy to understand in a good way. So let me go ahead. So what is a service map? So a service map is going to be a constantly updating diagram or map, hence the name, of your services and the interactions they have with each other. Each service is going to be shown as a bubble, and an arrow is going to connect the services. The value a service map brings is it's going to show in any environment how the different pieces or services are interacting with each other. And that's going to be, of course, an important portion of observability. And it's going to be even magnified at the microservice level. And let me just show the service maps rather than just talking on them. So here's an example of what's, oh yeah, that's right, it's a motion one, of service maps. So you'll see this shortly. If you're just kind of sneaking ahead, that's fine too. But what we have here is a service map. And let me go ahead, yeah, I'll just use the visual here for right now. But what we see are those components that make up, in this case, our coffee service. And in this case, the application is called the coffee bar. So that's when you come to Sumo Logic and you order your cup of coffee, you're using Coffee Bar app. So just for naming. But what we're seeing here are those components, those steps, those microservices of a transaction. So we see the coffee bar. We see on the left-hand side of the screen here, we see the coffee machine. We see the machine service. We see the water service and the coffee service that make up the machine service, that make up the coffee machine. On the right-hand side of the screen, we see those payment portions. So we have our cash desk, which is responsible for payments. But made up of the cash desk is an SQL account, a calculator service, and another SQL, a few SQLs going on in there. And this chart is showing us anomalies. So there's blue and red. Bottom left is showing us the legend. Blue is good or normal. Red is an error. So what we're seeing here is there's an error related to the coffee bar and coffee machine and coffee lover, a few different areas. As we mouse over these items, we start to see the data about what's causing that normality or errors. So as it mouses over here, we'll see here, and we'll look at this in a moment, we see there's a spike in latency. It's red. Well, that's concerning. And now we're starting to get information about what might have gone wrong or where it might go wrong. So let me go ahead and see service map walkthroughs. So yeah, that's what they look like. And when we do the lab for some of the other stuff, we'll go ahead and take a look at these. So we'll do hands-on in a moment, probably when we get back from break. What else about service maps? The other thing is you can configure as it says here, the anomaly detection. So the system is going to use automatic anomaly detection, but you can modify that, just more ability to fine-tune Sumo. Sometimes can be overkill, but you know, that's something that you can do. Yeah, that's really it for service maps. Let's see. Let's go ahead and do, let's do a little bit more here. So another slide section, and then we'll take our break. Timing wise, we're pretty good. So let's go through traces and spans. And we've started to already talk about this a little, but the visual is going to be important. So I'm going to use screenshots again. And then when we do the labs, of course, we'll actually get into it. But the screenshots are pretty good. Colin is asking, service maps are populated from the data, period. Yes, so they are automatically populated. Yeah, And we can help you get them set up if you don't see them. Not me specifically, but Sumo can. And I can also link documentation as well for that. But let's look at the traces and spans here. So alluded to these earlier, tracing walkthrough. So this is a tracing walkthrough. Now, this is a scary screen potentially, but let's simplify what's going on in here. What we're seeing here are very simply transactions of coffee orders. So on line 1, that trace ID, that was somebody's transaction. Line 2, somebody else's transaction. Line 3, so on and so forth. These are all individual transactions. Somebody came in, placed an order, hopefully got their order, and all is good. We see here the service. So in this, as mentioned, we're using the coffee lover, or I don't know if I mentioned that one, but we have a few different coffee names. So this is just filtered to show specifically coffee stuff. We see when it started. So when did the transaction start? Once again, when did the observer observe the transaction started? So keep that in mind. It's when did that kind of first thing kick off, not necessarily when the coffee order was received, but when it was placed. We see the duration. That's going to be pretty important for us. We want a fast cup of coffee. So a low versus a high duration is going to be relevant to us. We see, what else do we see here? We see a duration breakdown. We don't know the color schemes yet, but what this is starting to show us is, for example, for this first one, the green is representing the cash desk. So in this case, it looks like the cash desk took a while potentially. And we're starting to possibly gather some information about that. And then we have status codes, which we'll use, I think we use them today, as a way to indicate to us a successful transaction or not. In this case, a 200 is a successful transaction. Somebody ordered their cup of coffee, and 77 microseconds, which we'll pretend is possible, 77 microseconds later, they got their cup of coffee. Versus this one here, line that has an error of 503, this is indicating to us that there were errors during this process. And what we're going to play with is why those errors occurred. So we're going to dig in and, well, exactly that, figure out why those errors occurred. So we'll do that as a lab shortly as well. All right, so let's see what else I traces. So here's an example of an individual trace. I know it's kind of small on the screen. We'll see one, as I mentioned, in more detail pretty soon. But what we're starting to see are those services broken out. So on the top line here, I see the cash desk, I see the coffee machine. And then down below that, I start to see the microservices that might comprise those steps. So for example, and once again, I know it's hard to read here, in this crimson color, we have the coffee machine. And what we see here are the steps that the coffee machine needs to utilize of the espresso and preparing the coffee. And so we're getting that visual component there. Also can start to click on those things and zoom in on them, as you'll see when we do it live. Here on the top is an example of a successful order, which represented by the status code of a 200. So on the top, somebody got their cup of coffee in 120 microseconds. In the bottom, though, we have an error of 503. We have red, which means bad. And so in this case, somebody was not able to get our cup of coffee. What we're going to explore in the labs, I think we do it in the lab, and if not, we'll do it as a fun exercise because it's kind of cool, is we'll figure out what went wrong here. So why is this person not able to get their cup of coffee? So as mentioned, a successful order. So that's an example of tracing, and we'll do a hands-on exercise with that in a few moments. Let me see what these next group of slides are. Let's see. I'll go through spans real fast, and then we'll take a break, and then we'll come back and do our lab. So we have our traces, which are our transaction, if you will, and then broken out into the microservices or just the micro transactions called spans. Now with the span walkthrough, what we can do is we can start to filter specifically on our trace data at the raw span level. I'm kind of reading the definition here, so that we can start to understand the behavior of our application services. So this is going to allow us to go deeper. And so what we see here is the ability to take the information and look at it in spans. And so we'll do this as a lab as well shortly. What it's going to allow us to do, though, is to filter on specific spans so that we can look for those that are relevant. So if we only want to look at front-end activities or some sort of data, we can pull that quite easily. And then what we can do is we can start to filter those messages. The messages that we are going to see will be, well, we'll look at them later. I guess I don't want to give them away too much, but we'll take a look at those. And then we have some really helpful filtering capabilities. So why don't we go ahead and take a little break right now? I think this is a good spot. When we come back, we'll pick up with our hands-on exercise, more slides, and then we have a few exercises for the rest of today. So let me go ahead and put my timer. Let's do we can do another 10-minute timer. I think we'll still be good on time. So let's go ahead and take a break, get a beverage or a snack. Come back when you're ready, or when the timer is ready, rather, and then we'll go ahead and continue. And then we'll, like I said, do a few more labs, take the exam, and call it a day. So thanks, everybody, and talk to you in about 9 minutes. All right, welcome back, everybody. Hopefully you're coming back right now, or it's technically 10 seconds. But let's go ahead and start to continue. So what I think we're going to do now is we're just going to dive into the lab guide. I have more slides, but I want to do labs. They're more fun than just reading to you all day. So what we're going to do is we're going to do lab 2. So you may not be logged in. It may have kicked you out. Let me see. Yeah, it did for me. I need to change that timeout. So go ahead and log back into Sumo using those credentials that we put in earlier, and we can put them back in if you need. Security 21 exclamation point. And I'll go ahead and paste those credentials back in just in case you forgot them. All right, and so once you're logged in, go ahead and access that lab guide or vice versa. And so what we're going to do is I'm going to go ahead and close my so I can start off fresh, but we're going to go through lab 2. So lab 2 is going to now go through tracing the Sumo Logic Coffee app. So talked about the app. Now let's go ahead and actually play with it. So as it says, here's our scenario. We're trying to troubleshoot, figure out the root cause of something. As described, we're going to go ahead and look for a troubled order and figure out what's been the issue. So we're going to look for a transaction that's been unsuccessful and troubleshoot it. So first, we're going to go ahead and utilize the service maps. So what we want to do is we want to go to New Service Map. New Service Map. Now this service map, once again, is going to give a little story of what a service map is. Feel free to read it or interact with it. But for this case, what we want to do here is we want to filter just on the Coffee Bar app. The reason being is we're seeing Coffee Bar information here, but we're also seeing some other labs, some mobile banking stuff, Sumo Logic mobile banking, which is not related to coffee. So we just want to use the application name to specify the Coffee Bar app. And now what we're seeing is that service map that we saw earlier in a screenshot, but now live. Has a little more information. We've expanded it a little bit since that screenshot, but the same gist, if you will. We have our coffee bar, we have the different kind of services off of those, and then we have the different services, or I guess more microservices at this point, coming off that. So coffee machine, machine service, and then we have water and coffee. And what we see here is those reds showing us that there was an error. So what we see here is that there was an error or an anomaly, I guess technically not an error, but an anomaly of something going on. And so what we're going to do is we're going to try and figure out what. So we're going to use the coffee service here. It should be red on your screen. Fingers crossed it is. And what we can do is we can either just mouse over it to see some of the details and characteristics of what's going on or not going on. And what we see is when we mouse over it, the latency is an issue. Now what we can do is click on it. And now on the right-hand side of the screen, we're going to get that panel. We have a fancy name for it. They'll open up. And we're going to go and specifically look at traces. So what we want to do now is we basically recognize that in the service, in the coffee world, there's a problem with the coffee service. And now we want to look at some traces, look at some specific orders or transactions, and start to figure out what has gone wrong. So to do so, we're going to go to open in traces. And now we should be brought into the trace environment, which should look like that screen I showed earlier. A little bit different. The screenshot, actually, this has changed a little bit as well in the recently, but same idea. So what we're seeing in here are these individual orders. So here we're seeing order number 1, or not, 1, 2, 3, so on and so forth. We're seeing that duration. How long did it take to get that cup of coffee? Once again, remember, we're trying to do a fast cup of coffee. What we want to do here is we should, let's see. Yeah, let me go ahead and what I'm going to do is I'm going to select the first trace. And actually, let me see if this will work. Yeah, the first trace should Yeah, the first trace should be good. So your first trace might not match my first trace, and that's okay, but go ahead and select it. What I want to kind of zoom in on are the error spans. And that doesn't really help much. We need to kind of zoom in here. So what I'm trying to show here, what the system's actually trying to show us here, is things that have gone wrong. So we see that red horizontal line at the top level that's letting us know there's an error. Something's not quite right. Usually red is kind of bad. But what we want to do is we want to go to the lowest level of red, because that's going to show us at the microservice at the lowest level what is causing the red. So what we're going to do is we're going to go red, red, go lower, 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 lower. And then you should ideally have this blue line. You can zoom in, but you have to zoom in a lot. But what I want you to see, or at least observe, is that this bottom, either blue or brown, has a red line. And if it doesn't, try another trace. So what I'm looking for is a blue or brown that has a red line. Now, what does this red line mean? Well, what I can do is I can click on it. And then what I could do is I can open the logs that are associated with this span, with this portion of the transaction, to figure out what's going wrong here. Something here is wrong with the water service. If it was over here, it would be with the coffee service, but what's wrong? Well, let's find out. I'm going to click on this water service. I'm going to select, I can select actually either one of these. I'm going to select the span ID just so I get that, the portion that's relevant to me. And what I should see is an indication of what has gone wrong with the system. Going from the bottom to the top, these messages are in chronological order, reverse chronological order. So most recent is at the top. So what we see at the very bottom is the coffee order was received, needed water. What happened? Very simply, there was not enough water in the system. And so that's what caused that error. That's what caused this transaction to fail. What prevented Abel or our individual from getting their cup of coffee. If you had seen the brown one, it's a similar issue, but a little bit different. In this case, the order is received for coffee grains, and there's not enough coffee grains in the system. Oh, actually, this one did work, excuse me, because it was successful. But if you had clicked on one that had red, it would say not enough coffee grains. So what we're able to see visually is an indication of what's gone wrong. We're then able to dig into the logs and actually see what has gone wrong and can help us resolve it. Now, how do we resolve this issue of not enough water? Well, probably adding more water to the system. Maybe at a managerial level, we need to make sure that employees are filling the water reservoirs more frequently, or we get a bigger water reservoir, how we kind of fix this problem, but the system is letting us know. And so what we're able to see through technology, I don't know if it's that fancy, but somebody ordered a cup of coffee, what went wrong? We see here why. And this could be helpful if we're seeing, constantly in the California location, they're getting a lot of water errors. That might be relevant, of course, or helpful. All right, so that concludes lab 2. Any questions about that? Hopefully you got the power of that. The idea that you can really just kind of click around and see what's going on or not going on. All right, so that was lab 2. Let's go ahead and do lab 3. Yeah, let's just dive in. So what we're going to do with lab 3 is we're going to look at another use case, not Sumo Logic Coffee. This one is going to be, actually, it's Sumo Logic Coffee, but it's a different issue here. What we're going to do is, as an SRE, we're going to be on alert. And what we're seeing is end users are having a problem with the coffee app. Now, this time, the alert is related to a Lambda server. Previously, before break, we did the example of the problem related to DynamoDB, the EC2s, that type of thing. Well, different scenario here. So what we're going to do is try to utilize the logs to help us with observability. So we're really just going to follow the steps. We're going to go to New and Explore again, or maybe for the first time, but New and Explore. Once again, we want to change our Explore by view. By default, it's going to be the Kubernetes service view, which is not helpful unless we're interested in Kubernetes. And so we want to select that AWS observability. Now, once again, on the left-hand side of the screen, we can go ahead and start to dig into the different environments. So here we have 5 different environments, and we can go ahead and start to pick one to go into. The one we're going to use is, as we did earlier, we're going to use prod and use US East 1. So let's go ahead and wait a moment, make sure you can get into that. So now we're looking at US East 1 like we did earlier. Now we can, like we did earlier, we could go ahead and look at DynamoDB, we could look at application ELBs or whatever, but we want to look at Lambda because that's where the problem is. So we're going to go ahead and click on Lambda to specifically zoom in on that namespace, that product, if you will. Once again, we're getting graphical information, hopefully helpful, maybe not, but certainly relevant to Lambda. So locations, functions, et cetera, et cetera. So I want us to scroll down, or actually I want to make sure that we're in the Lambda overview first. So just by selecting Lambda, you should be in the, you will be in that first one. Some data might not load, which is not great, but I think we can still do the lab. Because what we want to do is we want to go ahead and scroll down to the bottom, or we want to notice at the bottom really here. What we see here are errors. Now remember, we're having problems with Lambda, and the system is showing us over the past 24 hours, there's been 8,000 errors. Over the past 24 hours, we've been having problems with Lambda, and there may be a correlation. There probably is. There better be if this is the lab, but let's go ahead and look into it. What we're going to do here is we're going to use the function name to use some filtering. We're going to filter specifically on get billing info. It should pop up as I start to type it. Billing info. Let's see. It's trying. There it goes. So it should have done it. There we go. Now it has the search ahead. So what I did is I'm saying just look at the billing info stuff, because that's what we're interested in here today, is things related to billing. It's also where a lot of the errors are happening, and that's where we want to draw your eye to figure out what's causing these errors. What we're going to do now is we're also going to utilize some logs as well, or get into the logs. So what we're going to do is we're going to go ahead to this successes and failures, and specifically to the success and failed requests here, right below it, we're going to click on the 3 dots and we're going to go to open in search. And what this is now going to show us are all those different log messages, about 720 of them or so. And it's going to show us that graphical representation we were just looking at, but what it's going to give us the power to do is click on messages and actually view the raw messages. So now what we're seeing are those raw messages of each error. Looks like a lot of invalid credentials, but let's go ahead and dig a little bit deeper, but that's what we're being shown here. Now what we can do here is on the left-hand side of the screen, we can use a filter. And hopefully, let's see, this should work as well. If we find our user, actually, we don't even need the filter. The log message is really right here. It's the invalid credentials. So what we're seeing here is the fact that the get billing info service or function keeps failing because of invalid credentials. And very simply, that's what we need to fix. Now, we didn't even really need to go into that deep because the system was actually, it wasn't telling us here that we didn't need to go to the log level. So by going to the log level, now we see what's causing those errors. We actually see the raw error message, and now we can go ahead and fix that. And so ideally we'd fix that. And once again, to prevent this in the future, maybe this credential, maybe we let somebody go who was utilizing these credentials and we should have not deleted their account. We should have just made them inactive, or how we fix this in the future is might be a managerial decision, but the system's letting us know this is what caused it. Okay. So let's go ahead and take a look at Lab 4. Now, Lab 4 is going into having us work with logs, and it's Well, it's important, of course. Logs are an important aspect of observability, but we're going to use the log query language here. So we're going to do a couple labs with logs. And so you may have used these features before. I really hope you have, but if not, let's demonstrate what these are and why they're important. And I do have a slide or two for these. This will probably be the last set of slides I really use. Where is it? So what I want to show is a log reduce and log compare. Let's just go into it. We don't need the slides. We don't need us thinking slides. So what I'm going to do here is I'm going to go ahead and grab the query in lab 4. It's a very simple query, but simple queries are good. What the query is doing is pulling CloudTrail data as we used on Tuesday. It's parsing the data. So we're parsing out the field of AWS region, and we're finding a count. So what we're seeing here is very simply the count of log messages associated with this region. Not necessarily errors, not necessarily Sumo Logic Coffee. We're back to just logs and looking at our system as a whole, or only CloudTrail data, excuse me, not as a whole, really just specifically CloudTrail data, I'm sorry. But we see the regions and we see the counts. And what we're going to do here is we're going to put it to the last 60 minutes just to get a little more data. It just helps the example. Okay. Now what I can do if I go to my messages is I see those individual messages. In that, my aggregations are showing me all the messages for each region. And now I'm viewing each message individually. Here's region 1, West 1, but I'm seeing the full message. Now, what I want to introduce here is log reduce. And it's kind of a weird spot to introduce log reduce, if I'm being honest, but you'll still get the feel for it. What log reduce is going to allow me to do, let me go ahead and click on it. Let me get rid of that count. So I'm going to remove my count, and now I'm going to search just for the AWS data. And now what I'm going to do is use log reduce. Now what log reduce is going to do for me is it's going to take all those different log messages. What were there? Hundreds of log messages, and it's going to sort through them all and display the results in groupings. In that, it's going to look at each log message and see, does it match the format of another log message? If it does, it's going to group it together, and it's going to continue to group it together. So what we're seeing here, and this is, I don't love this example, but it's fine for right now, is what we're seeing is our log messages are being grouped together by the contents of the logs. Specifically in this case, by the event version. So what we see is of those 11,000 logs, 6,000 of them are related to the event version of 1.06 with this format. 1,000 of them follow this format, and so on and so forth. And where this can become helpful is it can allow us to start to figure out groupings essentially of our data. Now this example, like I said, it's not that great. So let's just go to step 4 of this example. It's a different set of data. So I really should have just taken you there first because it illustrates much better. What I'm going to do is I'm going to grab this source category of labs/snort, fun to say, and I'm going to do it for the last 60 minutes. Now, what am I pulling? I'm pulling snort data, which is security event data. This is not Sumo Logic detecting these events, but this is some other outside system identifying security events. We'll kind of leave it at that. What I see is over the past 60 minutes, there's been about 6,000 of them. What I see, though, for each log message is information about the security event. Specifically, I see these brackets. I see potentially bad traffic. I see attempted information leak. I see sensitive data and other stuff. Now, what if I wanted to get, and this is what log reduce is really helpful for, and this is why it's going to be a better example. What if I wanted to get a quick understanding of the different classifications, the different groupings of data? How do I do that? Well, like I showed earlier, I can go ahead and do a count, and I could say count each classification through the query. But what I can do here, and what we're trying to show, the whole point of this lab, is log reduce. By clicking log reduce, what's going to happen is the system is going to take those 6,000 log messages and look at them and group them together as we start to see with the other data. Where it's going to be helpful here in this example, it's going to be much more illustrative. We now see of the 6,000 or whatever it was, 5,000 records, 2,900 of them are attempted information leaks. That might be concerning. It might not be, but certainly now we're starting to get a quantity. We see 1,400 of them were web application attacks. Once again, that might be concerning. It might be significant. Now, what I'm going to do, I know the steps in step 4 say to click on the count and click on the surrounding messages. I'm going to skip that for right now. I want to show the log compare operator first. And I'm going to skip the way that we show it in the example. I don't know why we use CloudTrail data. It works. Don't get me wrong. It works perfectly. It's just not a great example. It's not as engaging. So what I'm going to do here is, and I would like you to do it as well, is just click the log compare button and you'll see what it does, but I'll tell you what it does. Or before I tell you what it does, before I click it, let me tell you what it does, sorry. And feel free to click it. So what I know is over the past hour, there's been about 2,900 attempted information leaks. That's concerning. Or is it? Are 2,000 or 2,900 attempted information leaks over the past hour concerning to me as a security ops person? Yes or no? Kind of think about it for a moment. And your answer should be, I don't know. It kind of depends. It certainly sounds like a lot, but maybe it's normal. By using log compare, we can start to see if it's normal. In that, when I click log compare, what it's going to do is by default, it's going to go to the previous 24 hours, that 1 hour time period, and look at those same snort messages during that time period and compare them. So essentially what we're doing is we're looking at 10 o'clock to 11 o'clock today, seeing those messages and grouping them together. We're then going to 10 o'clock to 11 o'clock yesterday, looking at those log messages, grouping those together, and then showing the difference. And so what we see here is we've actually had an increase by 0.43% of attempted information leaks from yesterday to today. That's an increase. That might be bad. Conversely, we've had a decrease of web application attacks. That might be good. We don't have today any attempted denials of services, where we did have some of those yesterday. And so the system is now letting us know this happened, this didn't happen, and we can start to now evaluate or make a decision, at least in a semi-educated decision on, is this good, is this bad, is it improving, is it not? We could also set up alerts on these. So we could say the next time this gets to above 3%, email us. We don't go over those steps now, but we could set it up. It's not that hard. So I wanted to show you log reduce and log compare. Log reduce is a really important feature for Sumo Logic because, perfectly frank, it's what we got our first patent on. So we're really proud of how it works. Now, of course, we're not saying that no other company can take your data and group it together and find patterns, but the way we do it is unique, and the patent office agrees with us. And so wanted to show it off because, like I said, we're just kind of proud of that feature. So something you may use, may not, it's not required to use, but it is a helpful way to, once again, kind of observe what's going on. Now, in the lab, it did mention that portion about surrounding messages, and I do want to show that. So what I'm going to do is I'm going to click on, it doesn't really matter for today's exercise, I'm going to click on one of the counts. When I click on the counts, what it's showing me is those specific log messages. So when I click on this one that had a 2, I'm going to see those 2 attempted user privilege gain messages. And so I do. The feature we want to show you is called surrounding messages. What it's going to allow you to do is click on the, you can click on the host and do surrounding messages. And what's going to do is going to tell us a story, or ideally tell us a story about what's going on. This attempted user privilege gain didn't just happen. Something happened before it and after it. Maybe good, maybe irrelevant, but something happened. And the surrounding messages lets us view this. So what we're going to see when we run this is we're going to see the attempted user privilege gain. We're going to see that stuff that happened before it, and we're going to see that stuff that happened after it. And as you know your data, this can start to tell a story. So imagine, and we don't have the simple story here, but imagine Bob logs into, we don't have a Bob here. Yeah, no Bob's here today. So Bob logs into the system. He has a attempted information leak or attempted user privilege gain, and then he logs out of the system. And the logs are that straightforward. Well, the question should be, what the heck was Bob doing in the system? And that's what this can start to tell you. And so you can start to see all this stuff happened, then this event happened, and then this other stuff happened. And as you know your logs, you do start to see a story in there. It's kind of weird. you really can start to see what happens before and after, which is really helpful. So wanted to show that. The last feature we're showing today is log explain. It's a very specific feature. Let's go ahead and just address the slides on it. It's not something you're going to use that much, but it was something that our program manager wanted us to put in. What it is essentially, it allows you to dig deeper into log entries. In that, let's see, let me show an example of the log explain operator here. In that, it allows us to start to compare sets of, as it says, different logs. And so we can go ahead and look at these with a kind of a control group and a test group and start to look at the relevance between the two different ones. This is just, we can run through the lab. I'm happy to run the query. It's just not something that, I hope this isn't recorded and sent to my PM, but that's used that frequently. But let me show it since we went through the effort of making a lab out of it. What it's essentially doing is looking at these regions or whatever you want, any set of data, and starting to break them up into different groups. So here we're pulling CloudTrail data, we're pulling our fields, just parsing them out, and then we're using the log explain to look at the different buckets. And so it starts to give us a relevance column, which is going to be helpful of how close it's related to probability that the explanation occurs within the events of interest data set. Let me go ahead and pull a help article for this. It's just so specifically nerdy. Here's log explain. So I'll paste this into the chat. I don't think there's any exam questions on it. It's just something that you may want to use. The description I gave was not very sufficient, but if this piques your interest, let us know and we can certainly help you with it. All right, let me go back to my deck to keep us on track with time because I think we're pretty good. So summary, let's kind of wrap this up. And any questions, please ask. I know you guys have been pretty quiet over the past 2 days, and that, you know, I just hope you're getting something out of it. That's really my goal. And I feel like some of you are, so I feel accomplished. But summary for the group. So, you know, kind of as discussed here, with observability, you can certainly observe that app from the outside and understanding what's happening inside it. In case you need to track a transaction from end to end, you can do so in order to identify a particular service that was not functioning and what led to the unsuccessful transaction, and tracing is really going to be a great way to do that. Metrics on its own, while they can't give you the why and the who, they can provide deeper visibility and insight to help you understand the cause of a spike. And then you can gauge why an incident might have happened with the help of metrics. When you have an alert, we didn't really look at alerts, but an alert can occur on a specific function or resource, and then you can start to drill down on those relevant logs like we did with the service maps to start to see what might have gone wrong and what was the culprit and how to fix it. Certainly logs and metrics are quite different in nature, but they do, along with traces, form that foundation for observability. Next steps. You know, there's more of this. So we have an observability administration course. We're not doing that with you guys, but you're welcome to take it the next time we offer it, which should be probably soon. So, you know, next steps are learn more is really what we wanted to drive you to. But the observability admin, great course to ingest the data. So if that's something you want to do, I'd encourage you to either take the course, or there should be the labs that you can have access to through the, oh no, we don't have the labs in there yet. I'll send the labs to you guys, or at least a pointer to them. All right, and then to kind of wrap up, as a reminder, if you take the certification, which we're going to start in just a moment, and send us your certificate to training@sumologic.com. We'll send you that Uber Eats card. Also, we'll send you a backpack if you've completed 6 certifications. More classes coming up, so you've already attended one. I don't know why you'd really want to attend the Eastern or your APAC one, but you're welcome to. So thank you for all that. Let's go ahead and just talk about the exam and then get you in there. So once again, as yesterday or Tuesday, we want to make sure you take the exam as you, not as training user 579 or what have you. So make sure you log into your Sumo Logic account. If you want to keep the training account open and use a separate browser for your corporate or personal or professional account, that's fine. Yeah, either way, probably saying do it however you kind of survive Tuesday is probably best practice. As a reminder, once you log in, you'll go home or be brought home. You'll go to certification, and then you'll click Get Certified. Certification takes you to this certification portal, and then we're going to be looking at Cloud SIM. No, excuse me, we're going to be doing observability. And so under observability, there we go. We have the 2 exams, so fundamentals and admin. So just as a reminder, let me do that again, since I started to say the wrong thing. Go to learn, go specifically to the home Sumo Logic, then go to certification, then go to observability, and then select fundamentals exam. And same ground rules as before, open book, open Google, open documentation, 60 minutes, you're not gonna need that much time, 70% to pass, all that's the same. So yeah, let's go ahead and start the exam. Certainly if you want to start a little bit later, up to you, but that's really going to conclude today. We don't have an afternoon session. Hope you're not disappointed. Today was a short version, but thank you for attending. Certainly, if you have any feedback, please let us know. Go ahead and send it to training@sumologic.com. Any feedback, good or bad, I don't care. Feedback is helpful for us. I know these days are long, especially at Tuesday. And I know there was a little bumpiness in those labs that certainly I'll address, but anything you found that could be helpful or whatever, we are receptive. We really are. So, yeah, unless there's any other questions, I'm going to go ahead and I'll put myself on mute. Scott and I will kind of hang out for the next little bit, but once you're done, of course, just log off there. Like I said, no afternoon portion. We'll follow up with an email that has links to pretty much everything, the recordings, the slides, probably will have the labs in there as well. And so that will be coming out. I'll hedge my bet and say that it comes out tomorrow. If you don't get it by the end of tomorrow, just let us know at training as well. But thank you again. Thanks for attending, and yeah, good luck on the exam.